Now we're recording. We're good to go. So we're talking about what can and can't undergo Diels-Alder when we're talking about dienes. And so for dienes, we know we need two double bonds separated by a single bond. And what conformation do we need? Yes, so we need the diene to be in S-cis, and this was from the last session, but I'm going to delete it so we have space. Same with this. So we want our diene to be S-cis so that it can interact with the dienophile, right? So one thing that's really cool about dienes is it has the single bond in the middle. So if we have a trans diene, we can rotate it and make it cis most of the time. The only time we can't do that is if we have a super big bulky group or if we're locked in a ring. So I'll make a tiny note. Can't rotate in a ring and with big, bulky group. So we're going to go through these one by one, and you guys are going to tell me yes or no, can it undergo a Diels-Alder reaction? What do we think about A? No! So this is not just a regular old conjugated diene. This whole thing is conjugated. There's too much going on. This cannot undergo Diels-Alder. For number 2, is this a conjugated diene? Yes. Is it S-cis? No. Cool. Can we rotate it and make it S-cis? No, exactly. So we cannot rotate it, so this cannot undergo a Diels-Alder reaction. Cool. What's this? Is it cis or trans? It is S-trans. You are right. Can we rotate this bond? Yes, we can. So we can rotate it. And make it S-cis. So can this undergo Diels-Alder? And someone said I froze for a second. So basically, we can rotate this. We can rotate the single bond in the middle, and we can make it into S-cis. So yes, this one can in fact work. For this one, wow, if this would connect, that would be so super awesome. So for D, is it S-cis or S-trans? Yes, I agree. It is S-trans. And can we rotate it in the ring? No. So can D undergo Diels-Alder? No. Cool. I agree. So I'm going to go ahead and cross that out. All right. So what about E? What do we think about E? It's trans. Yeah, I agree. Can we rotate the single bond? Yes. Cool. I'm glad you said that. Because that's the trick. No, you cannot. And the reason you cannot is because the tert-butyl is the big bulky group. So tert-butyl. So if we have two tert-butyls, it is two sterically hindered, as someone said. To rotate. So it's not going to rotate. So this one cannot undergo Diels-Alder. If it was like this, could it undergo Diels-Alder? And then someone asked, so you can't always rotate single bonds? Yeah, exactly. So you can't rotate the single bond if it's in a ring or if it has a tert-butyl. And yes, so this one could undergo because it is a lot of sterics, you're right, but it's already in the S-cis conformation. So for the purposes of this class, this can work, this cannot. Because it's too sterically hindered to rotate, not necessarily to react. Does that make sense-ish? And then someone asked me to explain D and A again. So yeah. So A just has a lot going on, right? So this isn't just a conjugated diene. This is 1, 2, 3, 4, 5 double bonds in conjugation. So this is its own huge system. This is there's too much going on for it to react. I thought I was going to sneeze. So there's too much going on for this to react. For D, it's a conjugated diene, right? However, it's trans, and you cannot rotate this bond. The bond cannot be rotated because you're stuck in a ring. There's no way for you to twist that ring. And then they said, so too much conjugation isn't always good. So that molecule is super, super, super stable. So when we're talking about stability, it's really good. However, for the purposes of our reactions, you need specific conditions for specific reactions. So in this one, you need it to be a conjugated diene. That's it. So yes, there is such thing as too much conjugation. And then someone asked, D is trans? Yes, because the single bond in the middle is what we're looking at. And the double bonds are pointing opposite directions. So they're trans. If they were pointing the same direction, they would be cis. Any other questions about this one? If not, I am going to open the page. Okay, so let's do an easy-ish one to start out with. Let's say I gave you okay. So let's say I gave you this thing, right? I already oriented everything for you. We talked about the numbering and stuff, but now we're going to do like a real example. So, does anyone remember what I compared the diene to? Does anyone remember what I compared the diene to when we talked about the numbering and the reaction mechanism and things like that? And then I gave you a hint. Yes, like a crocodile or an alligator that goes chomp, chomp, chomp. So like the less than and greater than signs, we're going to compare this to a crocodile. And it's going to want to chomp up the dienophile. So we have to have the mouth open towards the dienophile. This is the mouth. The mouth is open to eat up the dienophile. Cool. Okay. So now we're going to number our crocodile. And we're going to start up top. And we're going to go 1, 2, 3, 4. Is everyone cool with that analogy? Are we good? Yes. Yay. Okay, cool. Super duper. For the dienophile, boring. We just say A and B. Not too much spice there. So now, 1 always connects to A. 4 always connects to B in this class. And we're going to start up top. And we go bam, bam, bam. A big old circle. So do you remember what we always form in a Diels-Alder reaction? What are we always forming? A ring, yes. For this class, do you remember what type of ring specifically? Careful, it's not benzene, but it's close. And yes, for this class, we're always going to do 3 arrows in the reaction because it's going to go in a circle. Not a benzene, very close. It's benzene without the double bonds. It's going to be a cyclohexane, excuse me. And so it's a 6-membered ring. So for the purposes of this class, we're pretty much always going to make a 6-membered ring. These are the bases. So the red is the new bonds that we made. The black is like the skeleton of the diene and the dienophile. And now we go in and add our substituents. So 1, 2, 3, 4, A, B. Our substituents are a methyl on 2 and a methyl on 3. Bam, bam. And we also have a CO2H on A. So this is our final product. This is really going to bother me, so I'm just going to fix it a little bit. Haha! Someone said with the color coding, they finally understand. Yay! And then, just in case anyone wasn't sure, this is the Chapter 13 handout. And yeah, this one example I added just now as a practice. But we are going to do the ones from the handout, yes. Okay, so now that we did this, we're going to do one step harder. And we're going to start out with... Yikes. Okay. I can do it. I can draw a 5-membered ring. That's good enough. Ta-da. And in the worksheet, I gave you this. So let's stick with that. Alrighty, friends. So now we're kind of in a predicament because the alligator's mouth is closed. Right? This is a ring. Everything is closed. So what do you think we're going to do? Any suggestions? I'm just going to give it to you. So we still have the alligator, we still have a chomp, but you can think of it as like, now there's something in the way, right? And if we look at how this is oriented, we see that the double bonds make up the top and bottom, and then the single bond is like in the back, right? So if you're chomping, this is the single bond, this part of your hand, this is the double bond, this is the double bond. So we're going to number 1, 2, 3, 4. This is always going to be A and B. And as some people said in the chat, we're going to form a bridge. So anytime you start with a ring, you end up with a bridge. So I'm going to draw this in 2D and in 3D. So we go, boop. 1 is always going to go to A. 4 is always going to go to B. And so we go bam, bam, bam. And I'm going to steal this base so I don't have to draw it again. Haha. All right, so when we draw it flat, we're going to draw our bridge head like so. And now we are going to draw our substituents. And then someone said, sorry. So yes, we are going to make the bridge, and the bridge is going to go up. You were correct. And then someone said, do we have to turn the ring like this? Yes, you do. So basically, we have to start with the number 1 up here, number 4 down here, and we have to orient it in a way that the pointy part is like facing the dienophile, excuse me. Okay, cool. So, we know that the diene has to be S-cis. What was the important note about the dienophile? Yes, I'll repeat my question. So, we know that the diene has to be S-cis. What did we say about the configuration of the dienophile? Yes, so we are maintaining the configuration. So we started cis, so we are going to end with cis. So either both groups are going to point up, or both groups are going to point down. And now we have to figure out which is going to be the case. So I'm going to draw this in 3D over here. And it shall look something like so. And the bridge goes up. And I'm going to duplicate this so I don't have to draw it again. The wonders of iPads. All right. So we can either have our groups pointing like such, or we can have them pointing. This looks so ugly. I'm sorry, drawing this in 3D is so much. Okay, close enough. I could use that, but I like this example better because it's more helpful for understanding, so I'm going to do that, but theoretically it could be whatever. All right, so which one do you think looks happier? A or B? And don't judge it based on my drawing skills, judge it based on steric hindrance. So we have a pretty even split so far. I'm going to say B because look at that. We have the bridge head. We have these two oxygens. All of them are like bumping into each other here, right? Here, they're kind of free on the bottom. Also, here, they're both pointing towards the double bond. So what's going to happen is the two carbonyls are going to stabilize the double bond. So you can think of it as another form of conjugation almost. And we're going to call this the exo product, and we're going to call this the endo product. In this class, the endo is always favorable. And since endo is down, we're going to say they're both dashed. And yes, I can repeat. So, endo is down, exo is up, right? And so what I mean by that and why one is more stable than the other is either the two groups are pointing up or they're pointing down. If they're pointing up, they're like clanking with the bridgehead. Everything's bumping into each other. They don't like it. Down here, they have more space, and also the double bonds in the carbonyl are going to interact with this double bond, and you get extra stability. You don't have to know how or why they interact because that's just complicated. If you do want to know, it's hyperconjugation. If you just know this word, that's enough for you. You don't have to understand the concept. Just know that because of this thing called hyperconjugation, these double bonds are going to stabilize this double bond, and the endo product is going to be super favorable. So, this applies when we have a bridgehead. So this one isn't going to be considered endo or exo, right? Also, if you had trans products here and one was up, one was down, you obviously can't pick endo or exo because you have one pointing each direction. If you only have one substituent, so let's say we just had, this, you can still call that endo and exo. So the only time you can't consider it endo or exo is if they're trans to one another or if there's no bridgehead. I'll zoom out so you can see the whole thing together. Does that make sense? Is anyone like completely lost? It's okay if you are. I just would like to know so I don't confuse you more. So someone said, so bridgehead plus trans equals endo or exo? No, it's the opposite. So bridgehead plus cis equals endo or exo. If it's trans, you can't do it at all. And between endo and exo, for the purposes of this class, we always want to pick endo. Okay, cool. So now we're going to take it one step further, and now we're going to do a whatever I just tried to draw. Oh my god, why can't I draw a 6-numbered ring? This, my friends, is why you shouldn't deprive yourself of sleep. You spend 20 minutes drawing a benzene ring. And I'm going to zoom up, scroll up just so I can see what I gave you. Alright, we're going to react it with this guy. So, it's pretty much the same as the one we just did, as far as like the numbering orientation thing, except now you have an extra, whatchamacallit in there. An extra carbon, sorry. So now instead of a 5-membered ring, this is a 6-membered ring, but the two pointies are still going to face the dienophile. We know that A connects to 1. We know that B connects to 2. Or, excuse me. B connects to 4, not 2. And we're going to go around in a circle. Ta-da! And so now we get our 6-membered ring. I'm sorry, I cannot handle that. All right. And so we have 2 substituents, but they are trans. So does it matter which one's pointing up and which one's pointing down? No. Awesome. I agree with you. So we'll just say, I already drew it, so this one can be going down. This one will be going up. And can we label this as endo or exo? And you know what? Someone pointed something out and I didn't explicitly say it. We are maintaining the configuration. So you're absolutely correct. It doesn't matter which one's up, which one's down, but they do have to be trans. Awesome. And we cannot label this as endo or exo product because, you know, there's one on each side. The thing that looks different than the one we just did is now we have 2 carbons in the bridgehead. So we have this little like point, and then we have a flat part, and then we have a point. So in 3D, this would look like so. One is pointing up, one is pointing down. Someone asked, does he ask for 3D answers? So yeah, sometimes he shows the answers in 2D, sometimes he shows them in 3D, so just kind of be familiar with that. Once you look at it once or twice, it shouldn't be too crazy, but yeah, I do recommend looking at it a couple times. Sorry, I have the hiccups. All right, and then we will do this one in the exam review because I do want to get to chapter 14. And I'm going to do these ones and that last one in the exam review so that we have some material to cover there. And then, yeah, I don't want to spend too much time. Did we do the first one? This one, I don't know if I'm going to cover it yet. Fine, whatever, let's just do it right now. Okay, so if he gives you this, which he probably won't, you're just going to do this reacting with itself. So it is going to be like a dimerization. So we connect A, B, 1, 2, 3, 4. Bam, bam, bam. So you end up with this. I actually hate how this looks, so I'm going to redraw it because I'm sure that was not helpful for anyone. This line, this line, this line are new, and we have a double bond here. So it's really ugly and students tend to get super confused, and he hasn't put one on the exam before, even though there was one in the exam review, so it might be on there. I'll cover it maybe in the exam review, but just know that it's going to go from 2 rings to 3 rings. That's the biggest takeaway from this. Any questions? Every time I don't cover something, I feel really guilty about it, but I hope you guys aren't, like, upset. So I'll keep this up for you for like a couple more seconds, and then I will go on to chapter 14. And as always, please let me know if you have any questions, comments, or concerns. And someone asked me to go back here real quick. While you're doing that, I will actually show you guys one of my favorite things that I own. It's a brain candle. Has a brain on it, and it changes color when you light it. Very fun. Okay. That's it. Thank you. I think it's cool too. I love brains. I also have like 100 boxes of glitter. It's fine. And yes, I can go back down. Ta-da. You can't see it, but it changes color. Yeah, you can't see it. Whatever. I see it. That's fine. Okay. Sorry. I thought I was going to sneeze. There's a lot of dust everywhere. Are we all good to go? Okay. Okay. So Huckle's rule basically states that in order for it to be aromatic, it has to be cyclic, planar, fully conjugated, and it has to have 4n plus 2 pi electrons. What people get tripped up about is n is not any kind of thing. Like, this isn't an equation that you're going to keep substituting, right? All this is telling you is that the number of pi electrons in the ring has to equal 4 times an interval, or times a real number, an integer, plus 2. So 2, 6, 10, 14, etc. For example, we have our best pal, benzene. Benzene is cyclic. It's fully conjugated, which is going to mean planar. And let's count the number of electrons. So we know that in the p orbitals, right, we're going to have 1 electron per double bond. And I know this is going to look overwhelming when I draw all the orbitals, but we did this in MO theory. So you guys are good. You know it. It's not scary. All we need to know is that since there is a double bond attached to each of these carbons, each of them have 1 electron in the p orbital. So in total, we have 1, 2, 3, 4, 5, 6 pi electrons. 6 is one of these numbers I gave you. It follows the 4n plus 2 rule, so we know that this is aromatic. I can explain it one more time if you guys would like me to, but is this sort of kind of making sense? Cool. Okay, so yes, someone said let's do the rating thing. That's what I was just going to do. So 0 means I have no idea what you're talking about whatsoever. 5 means I'm on board. I understand so far. Tell me how you feel. Ooh, we got 2 5s. We got a 2, and I'm proud of you. You're doing great. You're killing the game. Someone said 3.9. I appreciate how much thought you put into that. Someone said they prefer this chapter. Yeah, it's honestly pretty straightforward. You just have to memorize the rules, which I know some people hate, and that's also fine. We will get through it together. All right, someone said 4.4. Swaggy. Okay, so we're going to go on to anti-aromatic. So anti-aromatic, and okay, before I do that, someone said the equation is throwing me off. I get you. I totally get it. I was so confused when I learned this for the first time. So I'll give you the rosemary method when I'm done writing this. Okay. So the criteria to be NMR... What? Sorry. The criteria to be anti-aromatic... I don't know. The spirit of Dr. West just took over me for a second. So we're going to say 1, 2, 3, 4. The first 3 rules are exactly the same. So it's cyclic, planar, and fully conjugated. Someone said the almighty rosemary method saves lives. That comment by itself is going to get me through the week. Thank you. Okay, so then number 4 is a slightly different thing than aromatic. It's ever so slight, it's tiny, but you need to put it in your brain. 4N. Whoa. Okay, so 4N, pi, electrons. I'm being annoying and silly so that it kind of sticks in your brain, right? So for aromatic, it has to be 4N plus 2. For aromatic, it has to be 4N plus 2. For anti-aromatic, it has to be 4N. So it's going to be an interval of 4. So anti-aromatic, 4N. Criteria to be not aromatic is super straightforward. Break any rule. So if you break any of these rules, you are not aromatic. So something I like to tell people, if you see a radical, or more specifically an odd number of radicals, you have to be not aromatic. If you see an sp3 carbon, not automatic. My God. If you see an sp3 carbon, it's automatically not aromatic. If you see something that's linear, automatically not aromatic. If you see any number of electrons that is not 4N or 4N plus 2, it's not aromatic. All right, so here are the rules. I'll give you a moment to soak them up in your brains. And then I will make a little sticky note. I downloaded these cute little sticky note things, and they're just not efficient, but I like how they look. Okay. So they are pretty. Thank you for noticing. I live for the aesthetic, as you can clearly tell by my room. Okay. So let me title this. Nope, you can't see that whatsoever. That's better. Someone asked a question. I will answer it in uno momento. Okay, so this is going to be way more straightforward than what you guys are probably thinking. So aromatic. Anti-aromatic. And yes, I absolutely can zoom out in like one moment. Okay, so to be aromatic, the rule is 4n plus 2. To be anti-aromatic, it's 4n, right? So instead of thinking about it as an equation, as a whatever, we're just going to memorize these numbers, okay? So to be aromatic, you have to be either 2, 6, 10, 14. Is everyone kind of following the pattern? 18, etc. And so anything higher than 18 is iffy. So if we have something higher than 18, you kind of want to like be on the lookout, like, oh, this might not follow the planar rule. Anti-aromatic, 4n. Again, just memorize these numbers. So that's an ugly 4. And we can say on this side that higher than 16 is iffy for the same planar rule. Any number that is not in this set or this set is automatically not aromatic. I have a sneeze and a hiccup trying to happen at the same time. I might explode simultaneously. I mean, what's the word? Randomly combust. And I'm glad someone likes the color. That's my favorite color. Okay. I have zoomed out. Someone wants to know what I mean by linear. So linear is anything that's not a ring. And someone said LOL at the TM. Yeah, I like to be special, so. Alrighty. I don't know what I did to the screen, but the chat disappeared for a second, but I think it came back. Any questions, comments, concerns? On a scale of 1 to 10, 1 being well rested, and 10 being I'm literally asleep right now. How tired are you guys? 8, 6, 7. Oof. Yeah. I feel that. I really do. Okay. Off topic, but I was like, we need to have this heart-to-heart right now. I'm gonna skip the MO theory for now. We'll cover it in the exam review. It's not too much, but, you know, I just don't want to go over it right now. Aw, you guys are so sweet. You're the cutest beans in the whole world. Okay. Let's do some practice problems. Okay, so I will tell you, chapter 14, if you can do all of these problems, you are golden for the exam, for chapter 14. If you can do all these examples, you understand the concept, you are absolutely perfect for the exam. I mean, you're absolutely perfect anyway, but for the exam specifically. Okay, bam, let's zoom in. All right, let's go through these. We're going to do the first couple ones slowly, and then we're going to rapid fire through a couple of them. Okay, what are the rules? You can either type it or you can say it. It might be faster if you guys say it, but you don't have to. Cyclic, planar, fully conjugated. And to be aromatic, it's 4n plus 2. To be anti, it's 4n. Cool. First thing is first. Is this cyclic? Yes. Is it planar? And most people are thinking, I don't know, Rose, you didn't tell us what planar means. So we assume everything that is fully conjugated is planar until we get to 8 or more members in the ring. So yes, planar. Is this fully conjugated? So members just means how many things there are in the ring. So how many atoms, I guess. Is it fully conjugated? A couple people said yes. And then they immediately changed their answers because I did an outburst like that. Okay, so fully conjugated just means completely sp2. This carbon right here, my lovely darlings, has 2 hydrogens, so it's a sneaky little sp3. And he loves to do that because you will forget and you will be like, oh, we have a double bond, good to go. But no, watch out for those sp3s. I got one of those questions wrong on my exam, and I will never live it down. I will be upset about it forever. So don't make my mistake. Watch out for the sp3 carbon. Okay, so we broke one of the 3 rules. So automatically, what does this have to be? Not aromatic, correct. So Na means not aromatic. Super swagalicious. Okay. So for this second one, we have a cation. Cation means what hybridization? sp2, absolutely awesome. Cations, anions, radicals are going to be sp2 hybridized. Correct. So for this one, is it cyclic, planar, fully conjugated? Yay or nay? So I'll repeat. Is this cyclic, planar, and fully conjugated? I got 1 yes. Does anyone agree? Yes? Okay, cool. I agree as well. This is cyclic, planar, fully conjugated. And now we're going to count how many electrons there are. So how many pi electrons do you guys see? 2, and I agree. So let's just draw it out since it's the first example. 1, 2, plus sign means it's empty. So all together we have 2 pi electrons. So if we run back here to Rosemary's method, trademark, does this fall under aromatic or does it fall under anti-aromatic? Aromatic. Yay! So we're going to call this A for aromatic. Sweet. Okay. This next one. Is it cyclic? Is it a ring? Okay, someone said I'm lost, so we'll go through the next one a little bit more slowly, and hopefully we can get back on track. So for this next one, is it a ring? Is it cyclic? Yes, it is a ring, so check off the first box. Is it planar? Yes, because Rosemary said until it becomes 8 or more, you say yes. Cool. Is it fully conjugated? AKA, are all of these carbons sp2 hybridized? Yes. So it's cyclic, planar, fully conjugated. Sweet. So now let's draw out the yummy orbitals. So we have 1, 1, and we have a negative sign. So that means there's going to be 2 in here. And I know it's ugly, just let me live. So it's fully conjugated because all of these are sp2 hybridized carbons. So this one is a double bond, it's sp2. This one is a double bond, it's sp2. And this one is an anion. So being an anion makes you sp2. So fully conjugated equals all sp2 atoms. And we know cation, anion, and radical are sp2. All right, so let's start on the second row. We're going to leave those two in the corner for a moment. So is my main man right here, my main square, is he cyclic, planar, and fully conjugated? Yes, he is cyclic, planar, and fully conjugated. How many pi electrons do we have? Oh my gosh, wait, I'm so much right now. We didn't finish this one. I didn't tell you what the answer is. I'm so sorry. I need to chill. Whew. All right. So we have 4 pi electrons here, yes? Four pi electrons follows which rule? Aromatic or anti-aromatic? Anti, yes, I agree. So let's go back. It's anti-aromatic. You are correct. I apologize. I don't know why I decided I hate this ring and I don't want to do it anymore. So, yeah. And then someone said, how do you know which one to look at? I'm not sure exactly what you mean by that. We're basically looking at only the pi electrons, which are like the ones in the p orbitals. Okay, so someone said between aromatic and anti-aromatic. So we count the number of electrons, right? We know it's 4 pi electrons. And then we go back to the handy-dandy little thing I made. And we say if it's one of these numbers, it's aromatic. If it's one of these numbers, it's anti-aromatic. And that's kind of just how we know. Yep. I saw that light bulb go on from here. We'd love to see it. Okay. Cool. So this second one I changed up a little bit because I realized I had just copied and pasted it twice. So if you want to, on your handouts, get rid of the second double bond and do 2 radicals, that would be awesome. That's what I meant to give you. So Mr. Square, you guys already told me he's cyclic, planar, fully conjugated, and you also told me he has 4 pi electrons because we have 1 here, 1 here, 1 here, and 1 here. So 4 pi electrons, is that aromatic or is that anti-aromatic? Aromatic, I agree. Cool. Excuse me, I'm so dumb. Anti-aromatic, I agree. I saw AA and I was like, yeah, aromatic. So let's just go back up here and make sure. So 2, 6, 10, 14, 18 would be aromatic. 4, 8, 12, 16 will be anti-aromatic. So since we have 4 pi electrons, we know that it has to be aromatic. And then I feel really bad about what I just said. I kind of just blurted out, I'm so stupid. But I don't want you guys to think like that. If you got it wrong, that's fine. Even I make mistakes. So please don't feel bad. I didn't mean to hurt anyone's feelings with that. Okay, someone said they couldn't hear, but it's all good now. So I hope you can hear me. All right. So are we all okay with the one we just did? Does anyone want me to go over it again? Because I absolutely can. Okay, no comments, so I'm guessing I'll move on. And we started about 2:15-ish, so we'll end around 2:15-ish, but I don't want to waste too much of your time, so we'll do like 2 more examples. So, for this one, I said something about radicals. So what was the rule I said about radicals? Yes. So I said if there's an odd number, it's automatically not aromatic. But in this one, we have an even number, so we can't use like if you see a radical, you don't automatically say not aromatic. In this case, there's 2, so we unfortunately have to go through it. And someone said that they're confused about planar. So planar just means flat, right? So if we have our plane, when we have wedges and dashes and stuff, we're like pointing out of the plane. But if we're planar, we're flat. And so if we're sp2 hybridized, we're flat. And so what I mean when I say planar is if everything is sp2 hybridized, it's going to be flat on the plane. The only exception to that rule is if we have a really, really big ring, there's a lot of ring strain, so it might bend and not be on the plane anymore. So it won't be flat anymore. So what I was saying is, this is what an 8-membered ring looks like. So if it's this size or bigger, you have to like look at special rules. We'll talk about it in a little bit. But if it's anything smaller than this, you automatically just assume planar if it's fully conjugated. Does that make sense? Was that an adequate explanation? Kind of. Okay, I'll explain it again at the end if you still need some help. I totally understand this being confusing. It's a lot, and we're going pretty fast. Okay. So, for this one, is it cyclic? Yes. Okay. Is it fully conjugated? So, is it completely sp2? Yes, because we have double bond, radical, radical. So, awesome job. Yes. So, it being fully conjugated means it's going to be planar because it's a small ring, right? Now, how many pi electrons do we have? We still have 4, absolutely. So 4 pi electrons, and y'all know by now, 4 pi electrons means what? Anti-aromatic. Superstars. If we were in person, you would all get a gold star sticker. And I'm being completely genuine. I used to do that. Okay. So we are going to do one of the big rings, and then we're going to call it a day. Does that sound okay with everyone? I'm going to do that anyway, but I want it to be like you guys were included in the decision. All right, so let's go to this bad boy. All right, so we have 8 members in this ring, right? So it's really big. So once you see that, you automatically think to yourself, look out for planar. All right. Is it cyclic? Yes. Is it fully conjugated? Yes, because it's all double bonds. It's all sp2. So planar is on hold. We put a pin in it. And now I want you to tell me how many pi electrons there are. 8. All right, so 8 pi electrons. Does that fall under aromatic or anti-aromatic? Anti. Okay. Now, we talked about, aromatic, anti, non-aromatic. We didn't talk about the stability. So we know that aromatic is super stable. So stable that it turned my handwriting ugly, right? And non-aromatic and anti-aromatic are obviously less stable. Which one do you think is the least stable? Anti. Yes, so we're going to say anti. A sucks. Terrible, 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 terrible. We don't want that. We want to avoid that at all costs. And then non-aromatic. Just chilling. It's like, whatever. Meh. So remember, aromatic is super stable. Anti-aromatic sucks. And non-aromatic is like, meh. And whatever. Are we okay with that? In my mind, you all laughed at my little drawing. So thank you. You guys are great. I'll be here all week. Okay. I'm sorry. I'm just babbling at this point. So when we go back to the planar rule, right? It gets kind of confusing. So let me know if you have any questions. If we have 8 pi electrons and this thing remains flat, it will be anti-aromatic. And it's super unstable, right? Or it's such a big ring that it could just flip. So it turns into a boat. So let me get a handy dandy piece of a paper. So this is the ring, right? It's flat like this. And usually it likes to be flat because sp2 is stable, right? But this ring is so big that it wants to bend because the ring strain is so much for it. It's so tired. It's so strained. It works so hard, right? So what it wants to do is bend like this out of the plane. It wants to bend. And we can even make it more realistic. It can bend in 2 directions, right? If staying flat will make it aromatic, it will choose to stay flat. Because being aromatic makes up for the ring strain. If staying flat is going to make it anti-aromatic, it bends. Because it doesn't want to be extra sucky. So, that being said, in this case, if it stays flat, it will be extra sucky. It'll be anti-aromatic. If it bends out of the plane, it's now more stable. And if it breaks the planar rule, it's not anti-aromatic anymore. It's what? Non-aromatic. Perfect. So the actual answer is non-aro because it is more stable to break planar rule and avoid anti-aromatic. Does this sort of kind of maybe a little bit feel okay? I opened my mouth to say something and my computer made the weirdest noise. That was
I
odd.
just raised my hand and that's why.
Oh, okay, super. I didn't even know you could do that. Did you have a question?
So if the exam would have anti-aromatic and not aromatic as the answer, and I put anti-aromatic because I just follow all the other rules, will I have it wrong?
Okay, so you're kind of cutting out a little bit, but what I think you asked is if you had both anti and non-aromatic as an answer choice, which one would you pick for this example? If that's wrong, let me know. But in that case, you would have to pick non-aromatic because it chooses to be non-aromatic and not anti. So anti would be wrong. Did I accurately answer your question? Okay. If you had a different question and I just misheard you, please feel free to ask again. It was like choppy a little bit. And then someone asked a question about it being planar. And okay. Cheap Wi-Fi, I feel you. FAU's Wi-Fi sucks so much. And yeah, I feel you. Anyway, so when we're talking about planar, again, to reiterate, anything smaller than this ring size, so all of these don't get that choice. So we don't get to choose planar or not planar. We only get to bend out of the plane when we have a big ring like this. So first and foremost, that's very important. Next, I'm going to do my best. 1, 2, 3, 4, 5, 6, 7, 8. Ha ha ha! Bless notability. Okay, so now let's say we have this. So we have a cyclic, fully conjugated. And now we have 1, 2, 3, 4, 5, 6 pi electrons. So does this follow the aromatic or the anti-aromatic rule? Aromatic. Yes. So, since it's an 8-membered ring, it can either force itself to stay flat and become aromatic, or it can bend and be not aromatic. But what I said was if using the ring strain or overcoming the ring strain gets you to be aromatic, that ring is going to be like flat as a board. It's like, I don't care if I'm strained, I get to be aromatic. Being aromatic is cool. So it's going to choose to be planar in this case. So it will be planar. And it will be aromatic. So that's kind of how you pick whether it stays flat or it bends. So the reason it chose non-aromatic in the previous example is because you were choosing between anti-aromatic and not aromatic. And between those two, not aromatic is a better option because anti-aromatic is really unstable. We don't want that. But here, it's between aromatic and non-aromatic. And aromatic is much, much, much more stable than non-aromatic. So it chooses aromaticity. All right. At this point, we're going to do another check-in. 0 is I'm completely, absolutely, utterly lost. I don't know what you just said to me in the past hour. I'm confused. 5 is I feel great. I'm good. No questions. And while you pick, I'm going to answer a question in the chat. It said, which rule exactly did it break to be non-aromatic? So it was not planar. So it broke the planar rule. So it's cyclic and fully conjugated, but it bends out of the plane like this. So it's no longer planar. And that's why it's non-aromatic. All right, we got some 4.5s, we got a 4.8, we got a 3. You guys are killing the game. I love it. And yes, follow up to the question. They said, is this because it has 8 pi electrons? Yes. So since it has 8 pi electrons, it would be anti-aromatic, but instead of anti-aromatic, it's going to choose to bend out of the plane and become non-aromatic. Okay, 4.5. Yay. So bending equals non-aromatic. Yes, pretty much. You guys are killing it. Nobody's at a 0. So my day has been made. Yay. Even if you are at a 0 or at like a 1, that's okay. You're still doing amazing. I still heart you. You got this. You're killing it. You're here. I should be a life coach. Pep talks with Rosemary. Woo! All right. This is how you know the caffeine has kicked in too much. Okay, so someone said something. Thank you for reminding me, because I did want to bring it up. So you guys are like my main homies. No, I'm kidding. That was a weird thing to say. So you guys are like my regulars, right? And so I like to tell you guys things and get your opinion and whatnot. So I do have an exam 2 cheat sheet like I had for exam 1. My plan was to make a handout, send that to you tonight or tomorrow morning so we can fill it out in the exam review. And then I'll upload the exam review Friday night, Saturday morning. And then Sunday afternoon, send you the cheat sheets. Does anyone have any extremely strong opinions about that? Okay. Yes, I can repeat. Awesome. Okay, cool. So everyone seems pretty good. And someone had asked about the recordings. I don't even remember if it was this session or the last session. I am going to do my best to record it on a couple different devices so it's like it doesn't disappear. I have no idea what happened last time. I know WebEx like had an update, and I think the video was like too long. It was a corrupted file, whatever that means. So I'm going to record it in 3 different pieces. So every hour is going to be its own separate recording. And then I will post 3 different recordings to YouTube so it doesn't take like 27.5 years to upload. So yeah. I don't know if anyone here even asked that question, but there's the answer. And repeat what I said before is basically we're going to have our exam review Friday night. Or Friday afternoon, I should say. I will be uploading the exam review Friday night / Saturday morning. And then I will send the notes sheet Sunday evening. So you have time to look at everything yourself before I send the notes. And then your exam is Tuesday, I believe, the 29th. So you should have enough time to still like look through the notes and whatever. But I don't want that to be the only thing you study, because you got to do practice problems. Okay, so as always, I will stick around for a minute or 2, but that is all I had for you today. Thank you for coming. It was lovely to chat with you all. Me and my brain candle bid you a good evening. It doesn't have a smell. Yes, you can absolutely take a picture. Here we go. You're so very welcome. Here, let me actually try to make it as big as I can so you can see it. And if you want me to zoom into a specific part so you can take a picture, that's absolutely fine with me too. You're welcome. Have a great day. Okay, so I saw your email. Let me stop recording. Adios.